Hey guys, Mr. Catlin here. We just wrapped up lesson number 1 from Unit 3. Now we're jumping into lesson 2 as I open it up here on my screen. And lesson number 2 jumps right into naming some different parts of the circle. All right, so we got to identify some things. We got a circle here, H, labeled by the center. Lots of line segments and curves and distracting numbers or letters that are bouncing around the circle. And we just have to identify some of the things that it asks for. So lots of answers here that are actually would work. So it doesn't have to be the one that I pick. It just has to be one that is correct. So diameter, identifying a diameter on this has to start on one side and go all the way across and touch the other side and also touch the center. So that red line is a diameter. This blue line, I'm going to draw blue. This blue line right here is also a diameter. There's two diameters that would work here. You could use the line segment DG, which I just highlighted in blue there, or GD, if you put the letters in that order. And then the other one would be EA or AE. Same thing, just a different order of the numbers. Either one of those would be fine. You could use that. Now, lots of radii, plural for radius, in this picture. None of the curve stuff, okay? No, those aren't going to be. EC here is what we call a chord. We haven't talked about that, but it doesn't go through the center, so you don't want to use that one. But I'll highlight these in a darker shade or a thicker line, and I'll do all of these in a beautiful pink color, okay? That's a radius. That's a radius. That's a radius, and that's a radius, okay? So splitting these off here, actually, let's do it this way. This blue line is a radius. This red line is a radius. The pink one that I've already drawn down here is a radius, and this green line is a radius. So blue, red, green, pink, those are all radii, all right? So you can name any of those. I'm going to name them as the middle there. It's hard to see what it was now since I've drawn so much on there. H, right? So you could have DH. You could have EH. You could have AH. Or you could have GH. Any of those pairs would work for a radius. Okay? It does say to explain your reasoning, diameter is all the way across the circle. And this is from center to edge. So our explanations. All right, number 2. Lynn measured the diameter of a circle in 2 different directions. Measuring vertically, she got 3.5 centimeters, and measuring horizontally, she got 3.6 centimeters. Explain some possible reasons why these measurements differ. Okay, one reason might be it might not be a true circle. It could be a form of an ellipse or an oval. That could be true. It might not be a true circle. And then there also, the other thing that could happen here, this could just be human error. Maybe she just misread her ruler whenever she was measuring. Those are the 2 things that I could think of. A small test batch of lemonade used a 1/4 cup of sugar added to 1 cup of water and 1 cup of lemon juice. After confirming that it tasted good, a larger batch is going to be made with the same ratios using 10 cups of water. How much sugar should be added so that the large batch tastes the same as the test batch? Here's the key. Okay? I'm going to make a table here of the old batch versus the new larger batch. In the old batch, there was 1 water. In the new batch, there was 10 cups of water. In the old batch, there was 1/4 sugar. And in the old batch, or the smaller batch, there was a 1/4 cup of lemon. So to get from the old to the new, you'll notice that they had a constant of proportionality that was 10 times bigger. So all you got to do is 10 times 1/4, which would be 10 quarters sugar, and 1/4, same thing with the lemon, 10 quarters lemons. If you don't like improper fractions, get over it. Like them. Now, if you don't like them, you can convert that to 10 divided by 4, which is the same as 2.5 cups of sugar or 2.5 cups of lemon. Same thing with 10 cups of water. All right, last thing. The graph of a proportional relationship contains the point coordinates 3, 12. What is the constant of proportionality of this relationship? Well, if you have an XY table to show when X, this is X, when X is 3, and Y is 12, you can find your constant by simply dividing these two numbers to see that the constant is 4. So 4 is our answer there. Pretty easy stuff. Give me something harder. Homework problems. Come on.